Hello everyone. Welcome to a new chapter on transactions. An application, in order to be reliable, it has to handle several failures. For example, it could be hardware or software failures, network interruptions, system crashes, and even concurrent reads or writes, and the client's reading incorrect data due to partial updates. And transactions provide a mechanism to simplify these problems. A transaction is a logical grouping of operations where either all the operations are successful, which is called commit, and if some failure happens in the process, you can roll back these. And by using transactions, you can safely ignore certain potential error scenarios. And these are called safety guarantees. And the safety guarantees provided by transactions are described using the famous acronym called ACID: atomicity, consistency, isolation, and durability. Atomicity or atomic refers to something that cannot be broken down into smaller pieces. And in this context, it describes what happens if a client wants to make multiple writes, but a fault occurred after some of the writes were processed. If all these writes are part of an atomic transaction, then if the transaction could not be completed or committed, then the database provides the guarantee that none of the writes would be processed. And the application is safe to retry this set of writes again. That is the guarantee of atomicity. And the idea of consistency means that there are certain notions about your application which are invariants which must always be true. For example, in an accounting system, all your credits and debits across all the accounts should always be in sync. And this is not something that the database can guarantee by itself. It's the responsibility of the application to define its transactions correctly for it to satisfy these notions. And database database as atomicity, durability, and isolation properties can help in achieving the consistency, but it's not just on the database alone. Next comes isolation. Most databases are accessed by several clients at the same time. If they are reading different parts of the database, it's fine. But if they are reading the same parts of the database and updating them, then you could run into concurrency issues. And isolation in terms of ACID means that one transaction or one client should be isolated from the transactions or updates performed by any other client, and they cannot step on each other. And next comes isolation. Most databases are accessed by multiple clients at the same time. If they are accessing different parts of the database, it's fine. But if they're accessing the same set of records, then you could run into concurrency issues. And isolation, in this sense, means that if you have concurrent transactions running, they need to be isolated from each other. They cannot step on each other's toes. And when you have these, and with isolation, you are guaranteed that when transactions are committed, it looks like as if one transaction has executed after another transaction, but not at the same time. That's the guarantee that isolation provides. The last one is durability. Durability provides the guarantee that once a transaction is committed successfully, the data that it has written will not be forgotten. And in terms of a single node database, this means that the data update has been returned to a non volatile storage such as hard disk or SSD. And in terms of replicated databases, then the data is returned to some n number of nodes, and The database has to wait until these writes have been completed or replicated before sending a successful commit acknowledgements back to the client. But in there is no perfect durability uh, that is guaranteed, because imagine a scenario where you have all the database nodes and the replica nodes have all crashed at the same time. Then there is nothing we can do. So this is still a weak durability. Thank you.